Hello everyone, my name is Haun and I have a big problem. All the light bulbs in my house are burning out. All these burnt out light bulbs wouldn't be a problem if I was a caveman. Since I am not a caveman and need to light my home, I need to find the most efficient and cost-effective way to do so. Luckily, I am a junior in the Civil Engineering College at ASU and am enrolled in CE 300, also known as Engineering Business Practices. In CE 300, I have learned many skills that will help me make an informed decision when choosing a solution to my light bulb problem. Now, with many problems, the first step is research. After doing some research, I found three different types of light bulbs: incandescent, CFL, and LED. According to Energy Star, incandescent light bulbs, quote, create light by passing electricity through a metal filament until glowing occurs. Also, according to Energy Star, CFLs, or compact fluorescent lights, have electric current that is driven by gases in a tube, creating a reaction in which ultraviolet light turns into visible light through the fluorescent coating on the inside of the tube. And finally, according to Energy Star, LEDs are small light sources that become illuminated by the movement of electrons throughout semiconducting materials. The movement of electrons through the semiconducting material produces tiny light sources known as LEDs. When considering these three types of bulbs, energy loss must be taken into account. As can be seen in the figures shown, incandescent bulbs lose the highest amount of energy through heat, followed by CFLs, with LEDs having the least amount of energy loss. For simplification's sake, some assumptions have been made for this problem. Since there are so many different grades and brightnesses of bulbs, a brightness equivalent to that of a 60-watt incandescent bulb has been chosen for all three bulbs. From the Home Depot website, the lifespan of 1 year for incandescent bulbs, 9 years for CFL bulbs, and 18 years for LED bulbs has been chosen. From the SRP website, a cost of electricity of 10 cents per kilowatt hour has also been chosen. And finally, a length of analysis of 18 years has been chosen based on the lifespan of an LED bulb. When analyzing cost, some calculations must be made. This figure shows a calculation for the energy and replacement costs for CFL bulbs over an 18-year period. After doing the same calculation shown in the previous slide for all three bulbs, the following table has been made. Notice the initial cost of an LED bulb is $14.97, $1.24 for a CFL, and 37 cents for an incandescent. The cost of electricity per bulb is $21 for an LED, $14 for a CFL, $6 for an incandescent. The brightness and lumens are all pretty much the same for all three bulbs. The life of an LED bulb is 20,000 hours, a CFL bulb 10,000 hours, an incandescent bulb 1,000 hours, bringing the total cost of the bulb to $35.97 for an LED, $15.24 for a CFL, and $6.37 for an incandescent over each bulb's single-use lifetime. Now for the cost of 20,000 hours per bulb, we have $35.97 for an LED, $30.48 for a CFL, and $127.40 for an incandescent. As taught in CE 300, to begin analysis, it helps to visually represent the cost of each bulb over the 18-year analysis period. To do this, cash flow diagrams have been used. Cash flow diagrams are useful at visually representing the cost of each bulb over the analysis period. As can be seen in the figure, an arrow pointing up is a positive cash flow, or cash that is coming in, and an arrow pointing down is a negative cash flow, or cash that is flowing out. This figure shows the cash flow diagram for an LED bulb. The figure shows a $14.97 initial cost for the bulb and a $2.33 cost for electricity every 2 years thereafter. This figure shows the cash flow diagram for a CFL. The initial cost for a CFL is $1.24, which is lower than that of an LED. The cost of electricity for a CFL is $3.11 for every 2 years thereafter, with a $1.24 charge added after 8 years to replace the bulb. This final cash flow diagram is that for an incandescent bulb. There's a $1.47 charge for a 4-pack of incandescent bulbs, which is added every 4 years for replacement of the original bulbs. In addition, there's a $13.33 charge for electricity every 2 years. Here's a graphical representation of the cost of each kind of bulb over an 18-year period. As you can see, the initial cost of the incandescent and CFL bulbs are relatively close, with the LED being much higher. The effect that the higher energy use or lower efficiency of incandescent bulbs on total cost over 18 years can also be seen. When considering whether or not it is worth buying a more expensive bulb that uses less electricity, the net present value, or NPV, of the bulb is a useful tool. The NPV takes inflation into account when assessing the value of a bulb over time. For this case, the lowest NPV is desired because these bulbs are not making any money, they are saving money over time. When calculating net present value, a discount rate, or how much money spent now is worth in the future, is used. After completing a sensitivity analysis, I have determined that inflation and only inflation affects all three bulb types equally. This table shows inflation rates in the U.S. from 2003 to 2013, along with the average inflation rate over that time period. When calculating NPV for an 18-year period, Microsoft Excel is a useful tool. A sample calculation of the steps that Excel uses to calculate NPV is shown. This table was created after using Microsoft Excel to calculate the net present values for all three bulb types over the 18-year analysis period. As you can see, year 0 is the initial cost of each bulb, and years 2 through 18 are the electricity cost and replacement costs for each bulb. The discount rate is shown to be 4.76%, not 2.38%, because this analysis calls for values every 2 years. The final net present values for all three bulb types over the 18-year period are $16.74 for LEDs, $23.37 for CFLs, and $97.29 for incandescents. This graph shows the comparison of NPV values for all three bulbs over a 60-year period. A 60-year period was chosen to more clearly show the difference between the net present values for all three bulb types. It is clear that, as in the previous graph comparing bulb cost, the net present values of CFL and LED bulbs are much less than that of incandescent bulbs. It can also be seen that the NPV for LED bulbs is slightly lower than that of CFL bulbs. It also must be noted that the lowest net present value is the desired one in this situation because these bulbs are not making us any money, rather saving us money over a period of time. Now for a little wrap up. When considering incandescent bulbs, there is only one advantage, which is the low initial cost of the bulb. The clear disadvantage is the high amounts of electricity that incandescents use for relatively the same amount of light compared to CFLs or LEDs. The advantage of CFL bulbs is that they are less expensive than LEDs, but the disadvantage is that they need to be replaced more often and use more electricity. The advantage of LED bulbs is that they use less electricity than CFLs and incandescents, but the initial cost is much higher. And now for a final recommendation. Drum roll, please. All joking aside, CFL bulbs were chosen because of their relatively low initial cost as well as their low operating cost and lifespan. The reasoning behind this is, think of a family who wants to replace all of the bulbs in their house at the same time, with a house containing 25 light fixtures. LEDs would cost the family almost $375, while installing CFLs in 25 light fixtures would cost $31. There are other scenarios where LEDs can be phased into the home over time, but until LED technology progresses to the point that they become less expensive, CFLs are clearly the best choice. Thank you for watching, and I'll see you all next time.